Hello, everyone, and welcome to today's session. I'm Professor CompTIA, and I'm excited to guide you through mastering the OSI model for your Network Plus certification. Today, we'll explore the fundamentals of the OSI model, why it's essential for networking, and how it helps in troubleshooting and designing networks. This is a great starting point to strengthen your understanding and prepare for the certification exam. So, let's get started and dive into the world of networking layers. Now, moving on to slide 2, let's take a closer look at the introduction to the OSI model. The OSI model, which stands for Open Systems Interconnection Model, is essentially a framework that helps us understand how different computer systems communicate over a network. It's like a blueprint that breaks down the complex process of data transfer into manageable layers. This model is made up of 7 distinct layers, each with its own specific function, and understanding these layers is fundamental for anyone working in networking or IT. These layers work together in a structured way to ensure data travels smoothly from one device to another. Throughout this presentation, we'll explore each of these layers in detail, look at real-world examples to see how they apply, and discuss how mastering this model is essential for exam success and practical understanding alike. So, as we proceed, keep in mind that the OSI model isn't just theoretical. It's a practical tool that helps us troubleshoot, design, and understand networks more effectively. Welcome to slide 3, where we'll explore the fundamental framework that underpins all network communications, the OSI model. Now, OSI stands for Open Systems Interconnection, and it's essentially a conceptual way to understand how different devices communicate over a network. Think of it as a layered approach that breaks down complex processes into manageable parts. This model is divided into 7 distinct layers, each with its own specific role, from physical transmission of data all the way up to how humans interact with applications. The beauty of the OSI model is that it provides a common language for devices and developers, ensuring everyone on the same page when it comes to networking. Throughout this presentation, we'll see how these layers work together seamlessly to enable everything from simple emails to complex cloud services. Recognizing these layers helps us troubleshoot issues more effectively and design more efficient networks. So, understanding the OSI model is really about grasping the foundation of all modern networking. Now, let's take a closer look at the overview of the OSI model. Think of it as a detailed blueprint that helps us understand how data moves across different networks. It's really fundamental for anyone studying for the Network Plus certification because it provides a clear framework for how various network components communicate. Understanding the OSI model is crucial because it allows us to troubleshoot network issues more effectively. When problems arise, knowing which layer is involved helps us pinpoint where things might be going wrong. Plus, it helps us communicate more clearly about network problems, especially since the OSI model is applicable across various protocols and technologies. It's important to remember that the OSI model isn't tied to a specific protocol like TCP/IP. Instead, it serves as a universal language, a way for network professionals to understand and discuss different systems. Overall, becoming familiar with the OSI model is an essential step in mastering networking concepts, and it ties directly into the broader theme of understanding how networks operate and how we can keep them running smoothly. Now, let's take a closer look at the OSI model diagram on this slide. As you can see, the OSI model is divided into 7 distinct layers, each with its own specific role in network communication. From the physical layer at the bottom, which handles the actual transmission of raw data, to the application layer at the top, where user interactions occur. This layered approach helps us understand how data moves through a network in a structured way. Next to it, you'll see the network flow graphic. This visual illustrates how data originates from a source, passes through various network devices and layers, and finally reaches its destination. It highlights the journey of data packets as they traverse different points in the network, adapting and processing along the way. Connecting these visuals, it's important to remember that each layer in the OSI model corresponds to specific functions in the network flow. For example, Data is formatted and encapsulated at the presentation layer, routed at the network layer, and ultimately delivered to the application layer for user interaction. Understanding this flow is key to diagnosing issues and designing more efficient networks. Together, these diagrams reinforce the overall theme of how complex network communication is made manageable through layered architecture and clear data flow. They show us that, despite the complexity, each step is essential for reliable and secure data transmission. Now, let's take a closer look at the 7 layers of the OSI model. Think of this model as a universal language for how computers communicate over a network. Each layer has a specific role, and together they ensure data moves smoothly from one device to another. Starting from the bottom, the physical layer handles the actual transmission of raw bits over a physical connection. Think of it as the wires and signals. Next, the data link layer is responsible for framing and error detection, making sure the data packets are correctly packaged and sent without errors. Moving up, the network layer manages addressing and routing, so data finds its way across different networks, like GPS for data packets. The transport layer then takes care of reliable data transfer, ensuring everything arrives intact and in order, much like a courier service. Above that, the session layer manages connections and dialogues between devices, maintaining sessions so communication stays organized. The presentation layer acts as a translator or formatter. Think of converting data into a language both systems understand. Finally, the application layer is where users interact with the network, providing services like email or web browsing. Understanding these layers helps us see how complex, but coordinated the process of data communication truly is, and it ties into the overall theme of how networks operate seamlessly behind the scenes. Now let's take a look at a handy way to remember the order of the OSI layers. This is where the mnemonic comes into play. We arrange the layers from bottom to top, starting with physical, then data link, network, transport, session, presentation, and finally application. To help us memorize this sequence, we use the phrase, "Please do not throw sausage pizza away from the bottom, and all people seem to need data processing from the top." Think of it like a postal system or sending a letter. Each layer represents a step in the process of sending and receiving data, just like mailing a letter involves several stages. The analogy helps us see how data moves through these layers, kind of like sending a message through different stations. Imagine each layer as a step where something special happens, like wrapping the letter, addressing it, or choosing the right delivery method. And as the data travels from one layer to the next, it's like passing a letter along a chain of postal workers. This mnemonic is really useful because it simplifies something that seems complex at first glance. It's about understanding the flow, how data is encapsulated, transferred, and then decapsulated as it moves through the layers, just like a letter passing through various postal stages. So next time you need to recall the order of the OSI layers, remember the phrase and the postal analogy. It's a clear, visual way to keep everything straight. Now, let's take a closer look at the physical layer, which is the foundation of our network. This layer involves cables, signals, and raw data transmission. Think of it as the hardware side, wires, connectors, and the electrical or optical signals that carry data back and forth. Devices like hubs and repeaters operate here, helping to amplify or regenerate signals to keep data flowing smoothly. It's all about the physical connection and ensuring that bits can travel from one device to another. Moving up, we reach the data link layer. This layer is responsible for communication between devices on the same network. It uses MAC addresses to identify each device uniquely. Here, switches come into play. They direct data packets to the correct destination based on these addresses. Also, we have frames, which are packets of data organized in a way that makes error detection and correction possible. This layer ensures that data gets from one device to another reliably within a local environment. Next up is the network layer, which handles routing and addressing across different networks. It manages IP addresses, kind of like mailing addresses for devices, so data can find its way across the internet or other wide area networks. Protocols like IP and ICMP are essential here, helping with routing and error reporting. This layer ensures that data packets are directed correctly, even if they need to travel through multiple networks to reach their destination. Then we have the transport layer, which guarantees that data arrives intact and in the right order. Protocols like TCP and UDP operate here. TCP provides reliable, connection-oriented communication, while UDP is faster but less reliable. Think of this layer as the quality controller, managing segments of data, checking for errors, and ensuring everything gets delivered smoothly. It's also involved in diagnostics, helping identify where issues might occur along the way. The fifth layer, the session layer, manages the sessions or conversations between devices. It establishes, maintains, and terminates these sessions, ensuring that both sides are synchronized. It also handles translating, encrypting, and formatting data for the next layer, often involving security protocols like SSL or TLS to protect our data during transmission. Now, the presentation layer acts as the translator and formatter for data. It ensures that the data sent from one device can be understood by the other, regardless of differences in formats or encoding. Protocols like HTTP, SMTP, and FTP operate here, supporting web browsing, email, and file transfers. Essentially, it's the interface that prepares data for the user or application. Finally, at the top, we have the application layer. This is where user interactions happen directly. It provides the network services we use daily, like browsing websites, sending emails, or transferring files. All the detailed processes from the lower layers come together here to deliver a seamless experience. Connecting all these layers shows how each one plays a vital role in making our network communication reliable, secure, and efficient. Now, let's explore some real-world examples and applications of these concepts. What we see here is how the principles we've discussed actually come to life in various industries. For instance, you might think about how companies leverage data analytics to improve customer experience or optimize operations. These examples highlight the practical value of understanding and applying these ideas in everyday business scenarios. By connecting theory to practice, we see how these strategies can lead to tangible results, whether it's increasing efficiency, reducing costs, or enhancing innovation. It's important to recognize that these are not just abstract ideas. They are tools that can be adapted to different contexts and challenges. This reinforces the overall theme of the presentation, that understanding these concepts is crucial for real-world success. So, as we move forward, keep in mind how these examples mirror your own situations and opportunities for applying what we've learned today. All right, let's take a closer look at how Wireshark helps us analyze email transmission by breaking down the process through the OSI layers. When we capture email packets, what we're really seeing is a step-by-step journey of data as it moves across different layers of the network. Each layer adds its own set of structures or headers around the core data to ensure it can be properly transmitted and understood at the destination. This process is known as encapsulation. For example, at the application layer, you have the email content itself. As it moves down to the transport layer, protocols like TCP add their own headers to manage delivery, sequencing, and error checking. Then, at the network layer, IP adds its own header to determine where the packet should go. Finally, the data is framed at the data link layer for physical transmission over the network media. Understanding encapsulation is key because it helps us see how each layer builds upon the last to ensure reliable communication. When analyzing packets with Wireshark, recognizing these layered structures allows us to pinpoint issues or verify that data is being transmitted correctly. It's a practical demonstration of how the OSI model works in real-world scenarios, especially in something as common as email communication. This layered approach is fundamental to networking, and Wireshark puts it all into perspective for us. Now, let's take a closer look at how the TCP/IP model compares to the OSI model. As you can see, the TCP/IP model has 4 layers, and each of these corresponds in some way to the 7 layers of the OSI model. Understanding this mapping is crucial because it helps us see how different protocols fit into the bigger picture of network communication. For example, the TCP/IP application layer combines the functions of the OSI's application, presentation, and session layers. This simplifies things a bit, but it also means that some features are handled differently. The transport layer in TCP/IP aligns with the OSI's transport layer, focusing on end-to-end communication and reliability. Moving down, the Internet layer in TCP/IP is roughly equivalent to the network layer in OSI, responsible for addressing and routing packets. And finally, the link layer in TCP/IP covers both the OSI's data link and physical layers, dealing with how data actually moves across physical media. One key difference to highlight is that the OSI model was developed as a more theoretical framework, aiming for universal standards, whereas TCP/IP was built around practical, real-world protocols that we actually use today. Because of this, TCP/IP tends to be more straightforward and flexible in implementation. Understanding these differences is more than just academic. It has real implications for testing and troubleshooting. Knowing where a problem occurs in the layers helps us diagnose issues more efficiently. It also guides us in designing networks that are robust and interoperable. So, in summary, recognizing how these models relate helps us grasp the structure of network communications and improves our ability to manage and secure networks effectively. It's a foundational concept that ties everything else together in our study of networking. All right, as we wrap up, let's focus on some essential exam preparation tips and a quick summary of what we've covered. First, it's important to review all key concepts thoroughly. Don't just memorize, but really understand the material. Practice with past exams or quizzes to get familiar with the question styles and time management. Remember, staying organized and setting a study schedule can make a big difference in reducing stress and increasing confidence. Now, throughout this presentation, we've emphasized the importance of clear communication, understanding core principles, and applying practical strategies. These are the skills that will not only help you succeed in exams, but also in real-world scenarios. So, keep these concepts in mind as you prepare. And finally, stay positive and maintain a balanced approach. Rest, nutrition, and a bit of relaxation are just as crucial as studying. If you do that, you'll be well on your way to achieving your goals. Thanks for your attention, and best of luck with your exam preparations. Now, let's take a closer look at the 7 layers of the OSI model, their functions, and the protocol data units, or PDUs, associated with each one. Understanding these layers is crucial because each layer has a specific role in data communication, and knowing the PDUs helps us identify what kind of data is being transferred at each stage. For example, the physical layer deals with bits and hardware, while the application layer handles user data and applications. As we go through these layers, it's also important to familiarize ourselves with troubleshooting questions related to network issues. Being able to relate problems back to a specific layer can save a lot of time when diagnosing network troubles. For instance, if there's a connectivity problem, we might ask whether it's a physical connection issue, a configuration problem at the network layer, or something happening at the application level. I encourage you to practice these questions regularly, as they will reinforce your understanding of how the layers interact and where potential issues could originate. And don't forget, these concepts aren't just for exams, they're foundational for real-world network troubleshooting. Finally, I want to highlight that mastering the functions and PDUs of each layer is essential for your exam success. Combining this knowledge with strategic troubleshooting questions will make you more confident and capable in managing network problems efficiently. So, keep practicing, stay curious, and you'll master these concepts in no time. Now, as we come to the conclusion and motivation slide, I want to emphasize why the OSI model is so important and how it applies to real-world networking. Understanding the OSI model isn't just about memorizing layers. It's about gaining a structured way to visualize and troubleshoot network issues effectively. It helps you see how data flows through a network, which is crucial whether you're designing a system or solving a problem on the fly. Mastering this model really sets you up for success, especially when preparing for certifications like Network Plus. It's a foundational skill that translates directly into practical troubleshooting skills, so don't just think of it as theory. Think of it as a toolkit you'll use every day. And I want to encourage you to keep practicing. Hands-on tools, simulations, and even mnemonics can make the learning process more engaging and memorable. The more you practice, the more intuitive it becomes. So keep learning, stay curious, and remember, mastering the OSI model is a vital step toward becoming a confident, capable network professional. And here we are at the final slide, outro and engagement. I want to thank you all for your time and attention today. This is also the perfect moment to invite your questions, thoughts, or feedback. Remember, the key takeaway from this presentation is the importance of applying these insights to make a real impact. Your active engagement is what drives change and innovation forward. So, I encourage you to stay curious, stay connected, and continue exploring these ideas beyond today. And of course, I'd love to hear from you, so please don't hesitate to reach out or share your thoughts. Thank you once again for being here, and I look forward to our continued conversations. Thank you so much for sticking with me through this presentation. I truly appreciate your time and attention. If you found this video helpful, I'd love for you to like it, subscribe to the channel, and engage with the content by commenting or sharing your thoughts. Your interaction helps me create more of what you find valuable. And speaking of engagement, I want to hear from you. What are your toughest layers or challenges when it comes to this topic? Or maybe you have ideas for future videos you'd like to see. Your input is incredibly valuable because it helps shape the content to better serve your needs. So don't hesitate to share your experiences or suggest new topics. Remember, learning is a journey, and I'm here to support you every step of the way. Thanks again for watching, and I look forward to connecting with you in the comments or future videos. Thank you all for your time and attention today. I really appreciate you being here. As we wrap up, I want to leave you with a few final thoughts. Today's presentation was about the exciting potential of Afrobeats and how it's shaping the future of music and culture. We explored its origins, its global reach, and the innovative ways artists are pushing boundaries. The key takeaway is that Afrobeats isn't just a genre. It's a movement that connects people across different backgrounds and inspires new creative expressions worldwide. It's about embracing diversity, innovation, and the power of music to bring us together. I hope you've gained a deeper understanding of its significance and the opportunities it presents. Remember, this is just the beginning. There's so much more to come as Afrobeats continues to grow and evolve on the global stage. Thank you once again for being part of this journey today. I look forward to seeing how we all contribute to this exciting future. And of course, feel free to reach out if you'd like to discuss anything further. Thanks.